Hi students, good evening. So we are in the second session of wave optics, right? So already in the first session we have just talked about the introduction to the idea of wave optics and how these theories of light in terms of wave propagation have evolved. Okay, particularly we talked about the Huygens theory, which treated the light wave as a kind of a mechanical wave, where we will try to see the progress of the wave by using geometrical construction of the wavelets. Okay, before we go into the discussion about interference and diffraction, we will quickly revise some of the things that we have studied about the superposition of waves. Now the basic idea will remain the same whether we are talking about a light wave or any other wave. The basic idea of superimposing one wave over the other, right, will remain the same. And for most of the discussion, right, we will be limiting ourselves to the superimposing of two waves. Two waves means wave coming from two sources. Let us say we have two sources. Wave coming from both the sources will undergo interference at a particular point, any point you consider. So we will try to see this phenomena. Maybe sometimes in JEE advanced kind of level, we might even expect questions where we'll have three waves interfering. Okay, but the broad idea will be to look at the interference of the light wave coming from two sources. So today what we'll do is we'll try to cover the idea of interference of wave. Okay, so when interference of the waves is happening, we will see that there are going to be these two phenomena broadly. Okay, so one is what we call as an constructive interference, and second will be the destructive interference. So we'll see what are the conditions, specific conditions to achieve the constructive interference, and specific condition to achieve the destructive interference, because they will be useful when we talk about the Young's double slit experiment and single slit diffraction. So whatever the things that we are going to speak in case of the light wave, right, these two ideas will be required for us. Okay, first we'll begin with what is the basic idea of superposition of waves. What is the superposition principle? Okay, so if you have any point in space or any medium for that matter where two or more waves are approaching, what is a wave? It's like a disturbance only, right? Now think about it. So when you are in a calm water or a pond, you throw a stone in one place, it will create ripples on surface. You throw a stone somewhere else, the ripples coming from both the sources will try to overlap onto one another. They will try to create the combined disturbance. That is what you call as the overlapping of the waves or interference of the waves. We can say superposition of the waves. Okay, so if you have a point that you are choosing in the medium where two or more waves are approaching, the resultant displacement, because we are talking about the mechanical wave, right, the particles of the medium will be displaced. If the wave is moving say in one direction, transverse wave means the displacement of the particles will be transferred to the direction of the displacement. Longitudinal means like in the sound waves, right, the displacement of particles will be along the direction of propagation of wave. So here we will limit our discussion to mostly the transverse wave. Why? Because light is after all a transverse electromagnetic wave. Okay, so the displacement produced by whatever the number of waves, it may be 2, 3, it can be even more, it will be given by the vector sum of displacement. Why? Because displacement is a vector. It will be given by what? The resultant displacement is given by what? The vector sum of displacement produced by each of these waves. That's it. That is what we call as the principle of superposition. Now in our context, right, we are saying what? We look at mostly the cases where we'll have two sources, right? Let us say we have a source 1, source 2, marking a point P. At P, let us say the disturbance created by the source 1 is y1. We can say that is the displacement, and the displacement created by the source 2 is y2. The overall displacement is given by what? y1 plus y2, but we have to keep one thing in mind. What is it? It is not like simply saying 2 plus 3. This is what? It is a vector addition, and how do we account for this vector addition principle? Based on the phase difference. The propagating wave, right, will have a phase. Based on the phase difference, we will be able to account for the angle between the two displacements. So whatever is the phase difference, right, that is what we will be taking as the angle between the two vectors. The phase difference between the two waves, right, that arrive at the point P, that is what we will take as the angle between the two vectors. So we'll see how we will be able to find out the overall wave equation. So the overall wave equation is what? It will be given by y1 plus y2. From there we will see how we can find out the amplitude of that overall wave and the intensity, etc. So here we need to keep one thing. Intensity of any wave, right, will be proportional to what? Square of the amplitude. Either we will put small a or capital A, whichever it is. Intensity of any wave is proportional to what? Square of the amplitude. This is something that we will see in the waves and oscillation chapter also. Okay. So what we will do is we will look at the specific type of sources, because any two sources we can achieve the interference pattern. The superposition can be achieved. But to study the pattern, right, the pattern should be having a fixed arrangement in space with the time. Then only we can study, otherwise we cannot study. See, there is a point P, source 1, source 2. They are able to create a fixed displacement at point P, means we will be able to study it. But if it is keep on changing with respect to time, means we will not be able to study it, right? If whatever the displacement created at point P, because point P is general point, if it is keep on changing with respect to time, means we will not be able to easily study the pattern. So when we can get that fixed displacement, or the fixed interference, fixed means we are talking in terms of time, with respect to time this will not change. For this condition, right, we will be requiring what we call as a coherent sources. Later we will even see how that coherent sources will be able to produce the fixed interference pattern. So what is it? The coherent sources, right, will be able to produce fixed interference pattern. How they will produce, we will study that. But first let us look at what are these coherent sources. Coherent sources means the sources which will have same frequency or wavelength. Okay, the sources that will have same frequency or wavelength and identical waveform. Identical waveform means what? See, if one of them is a sinusoidal or cosine function, the other one also should be a sine or cosine function, because we can have a step waves also like this. These kind of waves are called as what? Step waves. Generally in digital circuits we will see these waves, right? So the wave pattern also should match. They should have what? Equal frequencies or wavelength, and the waveform should be identical. And the phase difference at the source, wherever we are producing these waves, right, the phase difference must be constant. It can be zero also. From the source where these waves are being released, the phase difference between these two sources should be what? Constant. It can be zero also. Okay. So if you have two sources like this, right, their frequency or wavelength must be same. Means they will both correspond to same color. That's it. Like yellow color light, green color light. Okay. They will have the same waveform, like sinusoidal or cosine. So these two we will not call as same waveform. One is the step function, other is a sine function. They are not identical. They should have the same identical waveform. So this can be sometimes, if at all we are getting some theoretical questions, they can even ask this as a question. So what is common for the coherent sources? Frequency, waveform, phase difference constant. Then they can give something like amplitude. See, here we are not talking about amplitude. We need to keep one thing in That very clear. Amplitude need not be same. The two sources, right, need not give us the same amplitude. But we will see after some time that if the amplitude is also same, because coherent sources amplitude did not be same, but if the amplitude is also same, right, then it will help us to see the difference between destructive interference and constructive interference very clearly. But that is not a requirement to get fixed interference pattern. Fixed interference pattern we can get by using what? Coherent sources. How it happens, we'll have to study that. As we go into the discussion, we will see. But coherent sources need not have the same amplitude. They can have different amplitudes. They have same amplitude means we will be able to clearly differentiate between which is an destructive interference place and which is a constructive interference place. We will see what is the reason for that also. Okay. So this is about the idea of the coherent sources. So here what you are saying, phase difference. The phase difference between the two sources, right, at the starting point will be same. Now these waves will have to travel some distance, right, from the source. They will have to travel some distance, like this one, right. We have a source S1, source S2. To reach point P, they have to travel distance. This is covering a distance of S1P. This is covering a distance of S2P. At the source, they have a fixed phase difference. Here S1P is a certain amount of path, S2P is another amount of path. We can see that there will be some path difference. So S2P minus S1P, or whichever is higher, this will be giving us what? Path difference. Now this path difference also will create what? Additional phase difference. So for example, for simplicity, right, let us say the source place phase difference is 0. We are saying it should be constant at the sources, but we are saying, let's say the sources phase difference is 0. Then while the waves are reaching point P, right, the overall phase difference will be only the one that is going to come as a result of the path difference. Now in waves +1 also we look at this conversion between the phase difference and path difference. Look at this. If you are covering a path difference of lambda, that will be corresponding to a phase difference of what? 2 pi. Path difference, let us say delta x is equal to lambda. That will give us what? A phase difference of how much? 2 pi. The conversion is what? The phase difference will be 2 pi by lambda into whatever the path difference. So let's say delta x is the path difference, right? So you can just put it. So if delta x is lambda, right, what is the phase difference going to be exactly? 2 pi. So delta x is equal to lambda. Accordingly, the phase difference will come as what? 4 pi. So this is the conversion between a phase difference and path difference. What is it? A path difference of lambda is equal to what? Phase difference of 2 pi. Okay. Now from the path difference, right, we can convert this into what is the equivalent phase difference. Okay. Now what we'll do is we'll start our discussion with the scenarios. But before we go there, right, so as a result of this superposition of the waves, what are we finally going to observe? We are going to observe the interference pattern. So in the space around these sources, we will observe what? Interference pattern. In this interference pattern, right, as we already said before, there are these two marked locations or locus, whatever we call it. One is the constructive interference regions. Second is the destructive interference. Constructive interference means the way we will be able to clearly observe, right? It is the place where the intensity recorded will be maximum. Like the intensity of the light will be what? Maximum. Destructive means the intensity of the light recorded will be what? Minimum. Okay. So constructive means intensity is going to be maximum. Destructive means what? Intensity is going to be minimum. So the constructive interference and destructive interference regions, right, they will be of importance for us to study the further aspects about the interference of light. Okay, whether it is the Young's double slit experiment or the diffraction through single slit, all these things, these two constructive interference, destructive interference, these two relations will be important for us. Okay, so we'll start with the first scenario where we talk about the constructive interference that is produced by two identical sources. Okay, so we are not just saying coherent. What we are saying identical sources. Okay, which means what? The wave that is reaching point P, let us say from the source 1, is given by A cos omega t. A is the amplitude. Zero path difference. So initially they are identical, means no phase difference will be there. Path difference is 0 means what? When they come here, they will again have no phase difference. So the wave that is coming from source 2 can be given by what? A cos omega t. So we are looking at the constructive interference that is happening from identical sources. Now identical sources means what? Coherent, plus there is one more additional condition, amplitude same. Initial phase difference is what? 0. So coherent means what? Frequencies or wavelength same, waveform is same, and the phase difference initially will be constant. But here when we talk about the identical sources, what are we assuming? They will be coherent. On top of it, amplitude same, and initial phase difference we are taking it as 0. Initial phase difference we are taking it as what? 0. Okay. Now if you have the 0 path difference, when they reach the point P, let us say path difference is 0. Path difference 0, when will it come? When S1P is equal to S2P. Okay. When path difference is 0 means phase difference also will be 0. Okay. Now what will be the overall displacement at the point P? Y1 plus Y2, that is equal to what? This plus this, right? That is the 2A cos omega t. Okay, so here you can see what is the amplitude here? A dash. What is A dash? 2 times A. What is the amplitude here? 2 times A. Okay, so if you look at the initial intensity for both these waves, right? Same amplitude. Okay, so initial intensity, let us take it as what? I naught. That will be same for both of them. We know I naught is proportional to what? A square. For the resultant wave, let us say the intensity is what? I. Okay, so what is this? I will be proportional to what? Here what is the amplitude? 2A, right? So 2A the square. Take a ratio, what we'll have? I by I naught is equal to what? 4A square by A square, that is 4. Which means I is equal to what? 4 times I naught. So if you have two identical sources, each having intensity I naught, at a place where we have 0 path difference, phase difference will be also 0. There we'll have what? Constructive interference. What are we going to achieve there? There will be constructive interference. We can see if each of these individual waves are having intensity I naught, the resultant wave pattern at that point P will have an intensity of how much? 4 times I naught. Okay, so this is one scenario where we can have the constructive interference. Okay, so again we will recall all these things when we go and discuss about the phenomena of double slit experiment and the diffraction. All these things we'll recall. Okay, so here we are trying to cover them from a general wave point of view. Okay, now we can also have constructive interference from these identical sources. When you see here there is a point Q we are marking. What is the path covered in the source 2? It is 9 lambda. Path covered by the light coming from source 1 is what? Here we will say light or wave. Path covered is what? 7 lambda. So you can see what is the path difference coming as? 2 lambda. What is the path difference coming as? 2 lambda. Means The equivalent phase difference is what? Remember just now only we saw that, right? 2 pi by lambda into delta x, right? Delta x means what? 2 lambda. So what is it? 4 pi. Path difference of 2 lambda is equal to what? Phase difference of 4 pi. Now if you say that the equation for the wave coming from the source 1 is like a cos omega t, then the equation for the wave coming from source 2, right? A cos omega t plus what is the phase difference? It will have 4 pi, right? Remember for cos, right? Cos of theta plus or minus 2n pi. N is an integer. Cos of theta plus or minus 2n pi is what? Cos theta. So which means cos of omega t plus 4 pi will be what? Cos omega t. Cos of omega t plus 4 pi will be what? Cos omega t only, which means again we'll have the same thing, right? The resultant will be equal to what? 2a cos omega t, and again here we'll have I is equal to what? 4 I naught. So here we are able to have construct interference when not only when the path difference is 2 lambda, if the path difference is lambda, if the path difference is 3 lambda, if the path difference is 4 lambda, if the path difference is n lambda, n is integer, the path difference is n lambda, then corresponding phase difference, right? It will be what? Look at this. Path difference of n lambda means phase difference will be what? 2 pi by lambda into n lambda, right? So lambda cancel. What is it? 2n pi. Corresponding phase difference will be what? 2n pi. N is an integer. So in those cases, right, what we will be ending up having? Constructive interference. So for the identical sources, right, what is the condition for the constructive interference? Either the path difference for the light from the sources reaching the point should be equal to n lambda. The corresponding phase difference will be what? 2n pi. Here n is what? Integer. Okay. So this is where we will be able to get the constructive interference. So these results will be important as we go into the further discussion, right? Where we are going to get the constructive interference and where we are going to get the destructive interference. Okay. Now let us see one example for the destructive interference. So look at this. We have wave coming from source 1, wave coming from source 2. They are reaching point R. The path covered is 9.75 lambda. These are some illustrative numbers, example numbers. Here what is it? 7.25 lambda. If you take the path difference, right, S2R, the path covered by the wave coming from source 2, minus S1R, path covered by the wave coming from source 1. What is it? 7.25 lambda minus 9.75 lambda. That is what? Minus 2.5 lambda. It can be negative also, right? It depends upon how you are subtracting. Okay. Now, if the path difference is minus 2.5 lambda, right, what is the corresponding phase difference? 2 pi by lambda into path difference. Minus 2.5 lambda. Lambda is cancelled. What is it? Minus 5 pi. So if you take the wave equation coming from the source 1 is what? A cos omega t. Then from source 2, here you see the phase difference is negative. Source 2 will be what? A cos omega t minus 5 pi. What is it? A cos omega t minus 5 pi. Now for the cos, right, for the cos we have another trigonometric identity. What is it? Cos of theta plus or minus 2n minus 1 into pi, means odd multiple of pi. N is an integer. Okay, so cos of theta plus or minus 2n minus 1 pi. Previously what we saw is cos of theta plus or minus 2n pi, that is even multiple of pi. This is odd multiple of pi. That will be equal to minus cos theta. That will be equal to minus cos theta. So you can see here cos of, this is omega t is like theta, minus this is like what? Odd multiple of pi. So what is it going to be? Minus a cos omega t. Now when you add both of them, right, what we will get? Y1 plus y2, add them, a cos omega t minus a cos omega t. What we will get? They are completely cancelling each other. Why they are able to completely cancel? Because the sources are basically identical. Since the amplitudes are what? Same. So as a result, what happens, wherever we have the constructive interference, we have completely bright. Wherever there is a destructive, we'll see complete darkness. So here the completely cancel means I will be equal to what? 0. Here the intensity also will be 0. We will see complete darkness. So that is the reason why I said the fixed interference pattern in the space we can see if we have coherent sources. But on top of it, if the sources are also having equal amplitude, right? Constructive means we will see maximum brightness. Destructive means it is like pitch dark. They will simply cancel. In case of light, if you are talking, the destructive means what? If the amplitudes are same, right, it will be what? Intensity will be 0. It will be completely dark. So which helps us to clearly differentiate between, maybe this can be another theoretical question, why sometimes people choose or prefer having the sources with equal amplitude means it will help us to differentiate easily between the constructive interference and the destructive interference, because one is like completely dark, other will be completely bright. Okay, so this is about the destructive interference cases. Now not only here what is the path difference we are having? What is the path difference? Minus 2.5 lambda, which we can say it is what? Minus 2.5 means 5 by 2, right? 2.5 means what? 5 by 2. Okay. So the generalized condition for the destructive interference is if the path difference is odd multiple of lambda by 2, means we can write it as what? 2n minus 1 into lambda by 2. N is an integer. Okay. The minus will come depending upon from which quantity you are subtracting. So same place, if I would have written like this, right, S1R minus S2R means what? It will be 2.5 lambda. Minus will come depending upon the way we subtract. Okay. So the cases where we have the path difference equal to odd multiple of lambda by 2. Constructive, what is it? Integer multiple of lambda. Here it is what? Odd multiple of lambda by 2. Okay. The corresponding phase difference will be what? Just the path difference. What is the phase difference formula? 2 pi by lambda into path difference, right? Okay. So lambda is cancelled, 2 is cancelled. What is it? 2n minus 1 into pi means we will get what? Odd multiple of pi. Okay. So either we will say in terms of the path difference or we will say in terms of phase difference. Path difference means what? Odd multiple of lambda by 2. Phase difference means what? Odd multiple of pi. In those cases, what we will get? Destructive interference. Okay. So this is about the basic understanding of the constructive interference and then destructive interference. Here we are using what? The identical sources. So we'll go one by one. First we are talking about the identical sources, which is very easy to understand. Okay. And slowly we'll complicate the things. Okay. Complicate means we'll try to look at the general coherent sources. Means general coherent means what? Their waveform will be same, the frequency will be same, and they will maintain constant phase difference at source, but their amplitude will be different. Okay, so that also we'll discuss later. But let us just summarize what we have seen, right? This is what the conditions for constructive and conditions for destructive. What is the condition for constructive? Phase difference means 2n pi. N is what? Integer including 0, because if you put n0 means phase difference is 0, corresponding path difference is also what? 0. That also we discussed. Okay, so the phase difference is what? 2n pi. Path difference is what? N lambda. N will be from 0 onwards, integer including 0. That is what is the condition for the constructive interference. Destructive means what? The phase difference will be 2n minus 1 into pi, and path difference is what? 2n minus 1 into lambda by 2. This is what? Odd multiple of lambda by 2. Phase difference, odd multiple of pi. Here our n value will be from 1. Here the n value will be from 1 onwards. Okay. So in some places what you will see is they will write it like this: 2n plus 1 into pi, 2n plus 1 into lambda by 2. There what they will say is n will be starting from 0. Okay, so either you will write, if you put 2n minus 1 means n will be starting from 1. If you put 2n plus 1 means n will be starting from 0. Don't think that these two are different. They are the same thing, right? Okay. So this is about the conditions of constructive and destructive interference. Okay. Now we will go to the next step, the general case. So we talked about what is the point where we will get the constructive, what is the point where we will get the destructive interference. But it is not like always we are going to have the path difference equal to n lambda, or path difference is equal to odd multiple of lambda by 2. You will have general points where the path difference will be some general delta x, and the corresponding phase difference will be some delta phi, or we can say phi. General scenario, general point. Okay. So at the general point, right, let us say the equation of the wave coming from source 1 is a cos omega t. Equation of the wave coming from source 2 is what? A cos omega t plus phi. This is a variable value. If you keep changing the phi means you will be able to cover all the points in the space, including the constructive place and destructive place also. Why? Because you will put phi is equal to even multiple of pi, that will cover all your constructive points. You put phi is equal to odd multiple of pi, that will cover all your destructive places. So this is the general scenario. Okay. Now if you have it like this, right, what will be the resultant wave at a point P? We simply have to add both of them, y1 plus y2, right? What it means? A cos omega t plus a cos omega t plus phi. A we can take out common. We'll have what? A into cos omega t plus phi. Okay. Now we can see something here. We'll have to, of course, simplify, because we are here trying to get the simplified formula, right? So you can see here, this is like what? Cos A plus cos B types, trigonometric simplification. What is cos A plus cos B? 2 cos A plus B by 2 into cos A minus B by 2. What is cos A plus cos B? 2 cos A plus B by 2 means what? 2 cos A plus, this is A, this is B. Omega t plus phi by 2 means this will be what? 2 cos omega t plus phi by 2. Cos A minus B by 2 means omega t plus phi minus omega t. That will be cos phi by 2. Okay. So here if you see, right, the variable part is where you have the time. Cos phi by 2 is also a constant factor depending on the phi value. Okay. So how we can write it? A is already there, so we can write it like this. A is there, 2 is there. We will take the cos phi by 2 also together. 2a cos phi by 2 into the variable part, time variable part. Okay, it's cos of omega t plus phi by 2. So how are we getting this? By using the trigonometric identity. Cos A plus cos B is what? 2 cos A plus B by 2 into cos A minus B by 2. Here this is the resultant wave, right? Now leaving out the variable part, what is the constant term? 2a cos phi by 2, that is our amplitude. What is the amplitude here? 2a cos phi by 2. So intensity here, right, what will be the intensity? We can say intensity is proportional to what? Square of the amplitude, means 4a square cos square phi by 2. Okay, so if you call the original intensity is I naught, for each of them intensity will be same, right? I naught is the original intensity of light from any source. I naught is proportional to a square. Take a ratio of them, what we will get? If you take a ratio means what we will get? I by I naught is equal to what? 4a square cos square phi by 2, okay, divided by a square. So we'll have I is equal to what? 4 I naught cos square phi by 2. What is it? This is the intensity at the point P. So depending upon the phi value, right? So we'll have two important results here. These two are important. So we'll just write it at the top so that we can remember them at the general point, right? Because these are the ones that will be useful for us while solving problems. At the general point for the superposition by the identical sources. So this is important. Superposition by the identical sources. That is what we are discussing. The amplitude A dash is a what? 2a cos phi by 2. Phi is the phase difference for the waves reaching the point P. And what is the I value? I is equal to 4 times I naught cos square phi by 2. So what is this? Intensity there will be what? 4 times I naught cos square phi by 2. Okay, so these are the two results that we need to keep in mind so that we will be able to. So this particular resultant wave expression, right? This may not be that much required, but these two values are important: amplitude and then intensity. So look at this. What is this? So even more than the amplitude, right? The intensity will be very important. So I will be equal to what? 4 I naught cos square phi by 2. Amplitude is what? 2a cos phi by 2. If you are able to remember both of them, means any question generally they'll try to ask on this. Okay, we'll in fact see. We'll see a question. Now look at this one. In the interference, two individual amplitudes are a naught each. Okay, identical sources like that they will mention. And the intensity is I naught each. Find the resultant amplitude and intensity at a point where the phase difference is 60 and the path difference is lambda by 3. Two cases. First we will see case here, right? What is the resultant amplitude? 2a naught cos phi by 2. Correct. And what is the intensity? I is equal to what? 4 I naught cos square phi by 2. Straight away we are putting the formula, right? So where is it coming from? Here. A dash is equal to what? 2a cos phi by 2. I is equal to what? 4 I naught cos square phi by 2. As it is, we are substituting the formula. That's why I said if you remember the formula, means we can answer these kind of questions very easily. That's it, right? Phi is what? 60. Means 2a naught cos of 60 by 2 means 30. What is cos 30? Root 3 by 2. So 2a naught root 3 by 2. 2 will be cancelled. That is what? Root 3 times a naught. Come on this side. 4 I naught cos square 30. Cos 30 is root 3 by 2. If you square it, means it will become what? 3 by 4. So 4 I naught into 3 by 4. 4 is cancelled. What is it? That's it, right? Check it, guys. Now I'll give you guys some time. You can tell me how we will get the answer for the second part, B part. B part is also almost similar. Difference is where here they are not giving us the phase difference. They are giving us the path difference, right? So we have to convert this into phase difference. That is it. In this case, what we need to do, we have to convert this into what? So look at the B. No, I'll just give you a hint and wait for some time. Here they are giving us the path difference lambda by 3. Means the corresponding phase difference is what? 2 pi by lambda into path difference. Correct? So if the path difference is lambda by 3, means what will be the corresponding phase difference? 2 pi by 3. That is 120. 2 pi by 3 means what? 120 only, right? That will be our case B. Because in most of the discussions, right, we will be focusing on the phase difference. Whenever they give a path difference, right, we will try to convert the path difference into phase difference. That is it. We'll try to convert that whatever the path difference given value into phase difference. So this is our, we're done with, we are going to B. What is the B case? Path difference is given, we got the phase difference, right? Again same. A is equal to what? 2a naught cos phi by 2. I is equal to 4 I naught cos square phi by 2. If you practice some questions, means these two results we will be able to just like that remember. Okay. So the thing is what here? the phase difference is not 60, it is what, 120, that's it. So 2a naught cos 120 by 2 means 60, right? Cos 60 is what, half. So in this case, what is the resultant amplitude? It is just a naught. Now look here, what is it? 4 times I naught cos square 60. What is cos square 60 means? Cos 60 is half. So half square, that is 4 I naught into 1 by 4. What is it? Interesting, right? At the point where we have the path difference lambda by 3, the amplitude, resultant amplitude is what? Same as the individual waves. Resultant intensity is what? Same as the intensity of the individual waves. Okay, so like this we can have some basic questions. Now this is what about the interference pattern because of two identical sources. Okay, now we can go to the actual thing, which is about the coherent sources. Coherent source means what? Already we said amplitudes need not be same. Like the wave equation coming from source 1 is what we'll say. Maybe we can keep the cos function itself, or we can, because a wave can be expressed either by using the cos function or by the sine function. Let us say we have the first wave coming from the source 1 is a sine omega t. The wave coming from the second source will be what? It will have a different amplitude. That is what we are saying. Coherent sources means that amplitude can be different. It will have an amplitude of what? B. So the phase difference we are taking it as what? Phi. So its equation will be what? B sine omega t plus phi. Amplitude is different. They will have some phase difference when they are reaching the point. What is the resultant wave? Y1 plus Y2, right? So we will simply have to add them. What is it? A sine omega t plus B sine omega t plus phi. So before we have to here again rearrange the thing so that we will get the final answer in a form that we can easily remember and easily use. So here we have it like what? Sine of a plus b types, right? We have it like what? Sine of a plus b. What is sine of a plus b formula? Sine a cos b plus cos a sine b, right? What is sine of a plus b? Sine a cos b plus cos a sine b. We will expand it. Okay, so if expand it means what? B into sine omega t cos phi plus again b is there, right? B into cos omega t sine phi. This is the derivation. Okay, so what we are going to do is we are going to derive the equation for the resultant wave, and from there we can even find what is the resultant intensity. Okay, so look at this. What is it? First step is we have written both these equations. Second, what we are doing, we are expanding that sine a plus b type function. Sine a plus b is what? Sine a cos b plus cos a sine b. Now I want you to look at two things. Look at this. Sine omega t is there, sine omega t is there. Okay, so if you take these two together, right, look at what we will get. Sine omega t we can take common. Remaining is what? A will be here, b cos phi. So a plus b cos phi into sine omega t. Second term is what? B sine phi into cos omega t. I'll tell you why we are writing it, because we have to simplify it, right? You again see here, this is like what? Sine omega t is coming in one place, cos omega t is coming in other place. We can try to simplify it. How? If we are able to express the a plus b cos phi as some r into cos theta, we will see what will be the importance of this r. So we can write a plus b cos phi as what? Some r into cos theta. B sin phi as some r into sin theta. If you write them like that, right, then you see what is going to happen. Here in place of a plus b cos phi we will get what? R cos theta. In place of b sin phi what we will get? R sin theta. Now you look at it. If you take the r common out, right, take the r common out, what we are going to have? If you take the r common out, what we will have? Cos theta sin omega t plus sine theta cos omega t. What is it? It is again like what? Sin A cos B plus cos A sin B, right? So if you take r common out, means that will be sine of A plus B, means sine of omega t plus theta. If you take r common out, means that is what? Sine of omega t plus theta. Now let us focus on this equation. This is the resultant wave equation. So here if you look at this, right, this is the variable part. R is the constant outside. So this R is the amplitude of the resultant wave. That's why we are keeping this with a symbol capital R. What is this capital R? R is the resultant wave amplitude. Okay. But what is this R? Initial waves, right? What are the equations? A sin omega t, B sin omega t plus phi. Here, finally what we are having? We are having in the final equation we have an R and we have a theta. Final equation we have an R and we have theta, right? So we will have to find out what is this R value and even what is the theta value. But more importantly, we are looking for R, right? That is the amplitude of the resultant wave. So how we will get the R value from these two? How we will get the R value? Because we have the two expressions, right? R cos theta is equal to what? A plus B cos phi. That is how we have substituted. R sin theta is equal to what? B sin phi. Take these two. R cos theta is equal to what? A plus B cos phi. R sin theta is equal to B sin phi. So generally whenever we are having this, cos theta sin theta, right, what is the first thing that will come to our mind? Square and add. That's it. Square and add them. If you square and add them, right, LHS, what is it? R square cos square theta plus R square sin square theta. What is it? R square into cos square theta plus sin square theta. What is this? 1. So LHS will be 1. RHS is what? A plus B cos phi the square, B sin phi the square. So we will simplify the RHS part. It's like what? X plus y the whole square. X square plus y square plus 2xy. Plus of course our B square sin square phi. See here, B square cos square phi plus B square sin square phi. What is it going to be? Again same thing, right? If you take B square common out, means cos square plus sin square phi is what? Same 1. So let's see what you will have. This is A square, then there will be B square, then 2AB cos phi. That is what? R square. So what is the R value? Root of A square plus B square plus 2AB cos phi. So you can see something interesting, right? In vector relation, generally if you have two vectors, vector A, vector B, angle between them is phi. That's why I said initially we will be able to get the resultant wave amplitude by using the vector kind of relation, right? You can see here, wave 1 amplitude is what? A. Wave 2 amplitude is what? B. What is the phase difference between them? Phi. It is like, the angle between the vectors is phi. What is the resultant vector formula? Root of A square plus B square plus 2AB cos phi, right? Same way we have this. So the resultant wave, if you have two coherent sources with the different amplitudes, when they reach the point P with a phase difference phi, what is the resultant wave amplitude there? Root of A square plus B square plus 2AB cos phi. This result we have to keep in mind because we can get some straight questions even in some of the previous year JEE mains as well as in NEET also they have asked. Okay. Now this is about this is what? The resultant wave amplitude. But we also have to talk about the intensity. See here the thing is, the intensities are different. For the first wave, right, I1 proportional to A square. So we can say like what? I1 is equal to some K into A square. I2 proportional to B square. We can say I2 is equal to some K into B square. The resultant wave intensity, right, that will be proportional to R square. Means we can say I is equal to what? Some K into R square. K is a constant. Now we have to find what is this I value in terms of I1 and I2. We have to find the I value, resultant wave intensity in terms of what? I1 and I2. For that what we will do is look at this now. We have this R square is equal to what? A square plus B square plus 2AB cos phi. Okay. Multiply both sides with K. Left hand side is what? K into R square. That is I. Here K into A square, I1. k into b square I2 to k into AB into cos phi. Okay, so here k into AB, right, we can write it like this, root k into A, then root k into B. I1 is what? K into A square. Take a square root on both sides. What you will get? Root k into A will be what? I1 is what? K into A square, right? We'll write it at the top. So look at this. I1 is what? K into A square. Take a root on both sides. Root I1 is equal to what? Root k into A. Similarly, root I2 will be what? Root k into B. So here root k into A is what? I1. Root I1. Root k into B is what? Root I2. Now from here we'll get the final result. What is it? I is equal to I1 plus I2 plus 2 times root I1 root I2 into cos phi. That's it. This is the final answer. So what is the final expression? The intensity, right? Intensity function is what? I. Intensity of that resultant wave will be what? I1 plus I2 plus 2 root I1 into root I2 into cos phi. Okay. So this is another important result. The resultant wave intensity and resultant wave amplitude. So what is the amplitude function? R is equal to what? Root of A square plus B square plus 2AB cos phi. This is like our general vector addition. What about the intensities? It will be different. I resultant is equal to what? I1 plus I2 plus 2 root I1 into cos phi. Maybe, you know, if you remember the resultant amplitude formula, right, from here itself we can try to derive it if required. Either you remember both of them or you remember one and try to derive the other whenever it is required. Okay, so this is about the resultant wave amplitude as well as the intensity. Okay, so now what we'll do is we'll just try to solve some quick questions. Before that, right, where we'll have constructive interference means, when we say constructive, right, what is it? The I will be maximum. Destructive means what? The I will be minimum. So in this case, in case of two identical sources, right, I minimum, destructive we got intensity 0, but here it will not be like that. So look at this now. This is the resultant wave intensity formula, right? In this, when we will get IR minimum, when cos phi is -1, that's when it will be minimum, right? So what is it going to be? I1 plus I2 minus 2 root of I1 I2. You know what is this basically? That is root I1 minus root I2 the whole square. Check it. If you take root I1 minus root I2 the whole square, right, it will be what? X square I1 plus y square minus 2xy. That's it. That is I minimum. You know what is I maximum? When cos phi will be 1. So what is it going to be? I1 plus I2 plus 2 root I1 I2. You know what this is? This is like a root I1 plus root I2 the whole square. That is the I maximum. Okay. So here you will see that I minimum will not be 0 because I1 and I2 values are different, right? I1 and I2 values will be different. They are having different amplitudes. Okay. So in this case, you know, that is why we said if you have two coherent sources with different amplitudes, you will have constructive interference I max point, you will have I minimum point, but I minimum will not be completely dark. So that is the reason why you see that there will be dullness. Minimum intensity means what? Dullness, but it will not be pitch dark. So to differentiate between the maxima minima or constructive and destructive interference, it will not be so easy. Okay, like it is in the case of identical sources. In that case, destructive means what? Complete 0. Here also put I1 is equal to I2, I minimum will be what? 0. That is what is identical sources, right? Identical means what? I1 equal to I2. Then I minimum will be what? 0. There it will help us to clearly differentiate between the constructive and the destructive. So sometimes we will even get questions on the ratio of these. Okay. So I max by I minimum. What is the ratio? Root I1 plus I2 the whole square divided by I1 minus root I1 minus root I2 the whole square. So if we take the, so what is this? I max by I minimum is what? Root I1 plus root I2 the square divided by root I1 minus root I2 the square. We can take the square as a whole and write like this. What is it? Root I1 plus root I2 divided by root I1 minus root I2 the whole square, like that it will come. Okay. Now this can even be expressed in terms of the amplitudes. This can even be expressed in terms of what? Amplitude. How? Root I1 is what? Root k into A plus root I2 is what? Root k into B. This is what? Root k into A minus root k into B the whole square. Cancel root k, what we'll have? A plus B the whole square divided by A minus B the whole square. In fact, if you look at it, right, what is the resultant amplitude in case of getting maximum intensity? It will be what? What is the resultant amplitude formula? A square plus B square plus 2AB cos phi, right? If cos phi is 1 means it's like what? A square plus B square plus 2AB. So R max will be what? A plus B. So this is root of A plus B the whole square is what? A plus B only, right? Similarly, R minimum will be A minus B, but we will have to take a modulus. R minimum will be what? It will be root of A square plus B square minus 2AB will come. That is like what? Root of A minus B the whole square. We can say A minus B provided A is more than B. We can say A minus B provided A is more than B. Otherwise, we have to put a modulus. Okay. So this is about the I max and I minimum. Here the thing is what? I minimum will not be 0. That is why we will not be able to clearly differentiate between the constructive site and the destructive site. Okay. So now we look at some sample questions on this. Two waves equal frequencies have their amplitudes in the ratio. Means this is A by B. What is the A by B ratio? 3 by 5. They are superimposed on each other. Calculate the ratio of the maximum minimum intensities. Means what? I max by I minimum they are asking. Just now only we saw it, right? What is the formula? I max by I minimum is what? A plus B the whole square divided by A minus B the whole square. A plus B the whole square divided by A minus B the whole square. But the problem is what? We don't know what is A, we don't know what is B. What we know is A by B we know. For that what we'll do? Numerator denominator, right? A plus B whole square divided by B square. A minus B whole square divided by B square. So take the B inside. It will be what? A by B plus 1 the whole square divided by A by B minus 1 the whole square. What is A by B? Means 3 by 5, right? Substitute. Okay. So what we'll get? 3 by 5 plus 1 divided by 3 by 5 minus 1 the whole square. 3 by 5 plus 1 means what? That is 8 by 5. 3 by 5 minus 1 means what? That is minus 2 by 5 whole square. 5 is cancelled. 2 1s are 2 4s are. What is it? 4 square means 16. What is the ratio, guys? There is a minus, but we are squaring it, right? Okay. So what is the ratio, guys? It will be what? 16:1. Next we look at another question. There are two current sources, intensities I and 4I. This is like what? I1 and I2. At a point P, light waves from both of them reach with a phase difference pi by 3. What is the phase difference? This is phi. Phi is what? Pi by 3. Find the resultant intensity. What is the formula? IR is equal to what? I1 plus I2 plus 2 root I1 I2 into cos phi. That's it, right? So what is it? I1 is what? I plus I2 is what? 4I. 2 into root of I into 4I cos pi by 3. This is what? 5I plus 2 into, inside we have root 4I square. That is another 2I. Cos pi by 3 means cos 60. What is cos 60? Half. So 5I plus 2I, that is going to be what? 7I. So at the point where the phase difference is pi by 3, what is the resultant intensity value? It will be what? 7I. Okay. So just based on the formulae for the coherent sources, right? The resultant amplitude equation, resultant intensity equation, and then that I max I minimum ratio. These are the formulae we need to keep in mind. Okay. And for the general construct interference condition, what is the construct interference condition? Path difference means n lambda. Phase difference means even multiple of pi. Destructive path difference is odd multiple of lambda by 2. Phase difference means odd multiple of pi. These things we will remember before we will go into the study of the wave related phenomena with regard to the light. Okay. So in the next class we will start with the Young's double slit experiment. Okay. So that is an important one where we generally JEE mains or even NEET, right? We do get even in advance also. But the advance, what happens is we can expect some questions on the modifications of the Young's double slit experiment. Okay. So we will start with the Young's double slit experiment in the next session. Okay. So all the very best and wish you a very happy new year in advance. So we'll just hope that the coming academic year, right? Coming year, we'll be able to see some really good success. Okay. All the best, guys.